The problem that we are going to discuss today is bitwise tuples. The problem appeared in June 21 long challenge and has a difficulty level of simple. The prerequisites to solve this problem are basic math. The problem statement goes as follows. Chef has two numbers, that is n and m. Now we have to find the total number of tuples containing n integers such that the integers are a1, a2 all the way up to an, and such that they follow this inequality, that is they lie in the range 0 to 2 to the power m minus 1. Also, along with that, these integers a1 to an, their bitwise AND should be 0. So it is given over here that the condition that is to be satisfied is that the bitwise AND operator, if applied between all these numbers, should result in 0. So we have to find all such number of tuples containing n integers. And since this number can be very large, we have to output the answer modulo 10 to the power 9 plus 7. So the question seems pretty simple, but note that the constraints are large, that is 10 to the power 5 test cases, and in each test case n and m can be at max 10 to the power 6. So before framing your solution, always keep the constraints in mind, and let's see how to write an efficient solution for this given problem. The solution approach goes as follows. The most important point in this problem is that you have to think in terms of binary representation of the numbers. Why? Because it was given in the question that the number m can be at max 10 to the power 6. And if you had paid close attention, the original numbers, that is a1, a2, a3 up to an, that are going to be in our tuples, they can range from 0 to 2 to the power m minus 1. So you can think that if m is 10 to the power 6, then this number is itself going to be very large. So numbers these big cannot be represented in popular programming languages. Hence, we have to think in terms of binary representation of the numbers. Why? Because if the value of m is given to us, then we can comment that how many bits are going to be present in our number. Like for example, if it is given that the value of m is 3, so all the numbers will lie between 0 and 2 to the power 3 minus 1. This is one way of seeing the question, but the other way of seeing the question is that all the numbers a1, a2 up to an can be at max of 3 bits, because this number 2 to the power 3 minus 1 is 2 to the power 3, 8, 8 minus 1 is 7. So the number 7 is nothing but 1, 1, 1 in binary system. So the maximum number can be of 3 bits and the minimum number is 0. So we can say that confidently all the numbers a1 to an will be of at max 3 bits. So this is the first main observation in the question, that you have to think in terms of binary representation while moving forward with the solution approach. So now we can say that we have reframed the question as follows. That is, we have to find the number of tuples a1, a2 up to an such that all these numbers are at max m bit numbers and their bitwise AND is 0. So each number is going to be at a maximum m bit number. So right now I don't know what the numbers are. So I'll just represent them using blanks. So there will be at max m blanks for each number. So let's say this is my number 1, this is number 2, and I have total of n numbers. Now each number is an m bit number. So 1, 2, 3, 4, total of m bits are there. And we have each number is of the same form, that is having m bits. So like this we are having total n numbers, each having m bits, and the main condition is that their bitwise AND is 0. So all that is left for us is to fill ones and zeros in this matrix or the grid, because the numbers in binary have either 1 or 0, right? So we have to fill all these positions by ones or zeros. or rather we have to find the total number of ways in which we can fill ones and zeros in this grid such that the bitwise AND is now 0. So let's see how to do that. So now we know that the bitwise AND, that is the resultant of all the n numbers using AND operator, should be 0 as per the question. That means that all the bits in the resultant number will also be 0. So I can write that the first bit will be 0, second bit, third bit, all the way up to mth bit. Now there can be many ways to fill the bits in the above grid such that the resultant bit is 0. But in only one case the resultant bit will be 1. That is, if we place 1 over here, 1, 1, all the bits are 1. In that case, the bitwise AND will become 1, which will violate our condition. So whatever we do, we just have to take care that all of them should not be 1. Rest anything is allowed. Okay, because if all of them are 1, then the resultant bit will be 1. And if any of these bits is 1, then the bitwise AND will be non-zero. And it is given in the question that it should be clearly 0. So we have to fill the bits in this above grid in such a way that all these below bits should remain 0. So how to do that? Basic combinatorics will work. So there are total n positions present for each bit. That is, for the first bit I can see that there are 1, 2, 3, total n positions. Now in each of these positions I can fill either a 1 or a 0, a 1 or a 0, again a 1 or a 0. So each position has two options. So if I use combinatorics, the total number of ways in which I can fill ones and zeros in all these positions, I'm just talking about the first bit, it will be 2 to the power n, right? Because 2 into 2 into 2, and we have total n positions to fill, and each of them has two options. So 2 to the power n total ways for the first bit, but out of them, one way is not allowed for us. Which one? The one in which all the bits are 1. So total possible way or total allowed ways are 2 to the power n minus 1 for the first bit. So 2 to the power n minus 1, this is for the first bit. Similarly, for second bit also the condition is going to be same. Same story again. We have n uh, available positions. Each bit can take two options, 1 or 0. So 2 to the power n total options, but one of them is not allowed. That is all ones. So we'll subtract that. So the formula that you will get finally is that for each bit 2 to the power n minus 1 ways, and there are total m bits. So multiply these m times. So this is the answer that you get. 2 to the power n minus 1 whole to the power m. So this is the final answer. Now the input gives us n, the input also gives us m. So calculating this number shouldn't be very hard. But only the thing that you have to keep in mind is that this value can be enormous because the values of n and m can be up to 10 to the power 6. And also the answer that we have to give should be reported modulo 10 to the power 9 plus 7. So if you have got this formula, your question is basically done. Only thing that you need to know is how to do modulo operations. And that will be taken care in the implementation part. So the implementation goes as follows. First of all, I am going to do the modulo operations in C++ language. So I have written my own template for performing the operations, common operations like addition, multiplication, subtraction, and power function. So these are modulo functions, meaning that the answer will always be in the range 0 to mod minus 1. So the code begins as follows. We just take the number of test cases as input. For each test case, I take the input for n and m. And after that, I directly have the formula that is 2 to the power n minus 1 whole to the power m. So I just have to implement that formula using my functions. So first of all, 2 to the power n minus 1, that can be written in this manner. That is, I am subtracting 1 from 2 to the power n. So all operations have to be modulo operations so that the answer is not wrong. So once that is done, I have to do that part whole to the power m. So that is again done using this bigger power function. So why to use your own power function? So basically this power function which I have written, this is called as binary exponentiation, and it does, it finds you the power in logarithmic time of the whatever is the exponent. So because the constraints were large, we cannot write a for loop or use the inbuilt power function. So for doing it in less time or using an efficient function, you have to use binary exponentiation. So you can read more about it on the internet, but basically that was the concept in the question, that once you find the formula, you have to use your own power function, that is, let's say binary exponentiation, or in Python it's predefined, so you can use that as well to find the answer. So we just find the answer and output it for each test case. So the implementation is simple if you have these templates with you beforehand and just find the formula. So that completes with our solution. Now I would like to tell you guys about the competitive programming tutorials. So if you are new to CP and want to learn topics, then you can head over to our page CP tutorials and find all the topics about CP that are taught by our expert educators, and you can access them for free over here. Also, if you want even more structured content, problem solving, doubt discussion, you can opt for the plus subscription on Unacademy, where you can use my referral code Darshan 25 to get instant 10% discount.